Welcome back to the deep dive. Now, if you are gearing up for your air transport pilot license theory exams, well, this deep dive is absolutely for you. We are diving headfirst into future air navigation systems, that's FANS, and the technology really at its heart, data link. Our mission today is pretty sharp. We want to pull out and really hammer home those specific high-yield knowledge points, things about CNS ATM architecture, data link operations, the stuff that really makes a difference in passing those exams.
Yeah, that's spot on. FANS isn't just some vague idea. It's a very specific technical framework.
Yeah.
You absolutely need to understand why the old system didn't cut it anymore. And then, the architecture of the new system, and crucially, how these systems actually work differently depending on where you are in the world. We're really aiming for you to have perfect recall on the definitions, the key organizations involved, and importantly, the step-by-step sequences of how things operate.
Okay, great. So let's start by setting the scene. What was the fundamental problem FANS was trying to fix? I mean, when you think about air traffic control, over land, close to cities and stuff, ATC uses ground radar and pretty reliable VHF voice comms. That gives them what we call positive control, right? They can literally see you on a scope and talk to you instantly.
Exactly. Positive control. But, most of the planet isn't populated landmass. It's oceans, deserts, polar regions, vast remote areas. And once you fly beyond the reach of that VHF radio and the ground radar, say you're crossing the North Atlantic or flying over the Sahara Desert, that positive control just disappears. In those places, ATC has to fall back on something called procedural control. This relies heavily on pilots reporting their estimated positions and the main communication tool. It's high-frequency radio, HF.
And procedural control. Well, that sounds quite restrictive, doesn't it? Maybe okay back when there weren't many planes, but surely a bottleneck now.
Oh, a massive bottleneck. Procedural control basically means ATC has to work on the assumption that they don't know exactly where you are between those position reports. There's a degree of uncertainty. So for safety, they have to mandate really, really big separation distances, vertically, side to side, and front to back. And the immediate effect of that is it just throttles the capacity of that airspace. Airlines might have to fly longer routes, burn more fuel, just to maintain that safety buffer.
The source material gives that classic North Atlantic example, which really highlights the issue. Just how far apart are those position reports in reality?
There are huge gaps, both in distance and time. Over the North Atlantic, pilots only need to report their position every 10 degrees of longitude, up to 70 degrees north. North of that, it stretches out to every 20 degrees. Now, if you're in a fast jet, that means ATC might only get an update on where you are every 30 to 60 minutes, half an hour, maybe even an hour between updates. You just can't manage busy airspace safely or efficiently with position data that old. It's impossible.
Okay, so the push for FANS really came from the fact that the old voice systems, VHF and HF, just couldn't cope with modern traffic levels. Let's really nail down the specific problems with VHF and HF. This is absolutely crucial stuff for you to know for the exams.
Okay, let's start with VHF. Its big weakness, its Achilles heel, is that it's line of sight only. That's just physics. Even if you're flying high, say flight level 300, the practical range is limited to about 200 nautical miles from the transmitter on the ground. Any further, the signal just can't curve around the Earth. You lose contact.
Right. So for longer distances, you had to rely on HF. But that came with a whole different bunch of problems, didn't it? Problems that weren't just about range.
Oh, definitely. HF is, frankly, notorious for being unreliable. It gets plagued by static interference, crackling, hissing, and fading the signal strength can just drop out unpredictably due to things like atmospheric conditions, solar flares, that kind of stuff. And this often leads to really frustrating comms, messages having to be repeated over and over. Or sometimes they even have to be relayed through a third party, like another aircraft nearby, because the pilot can't talk directly to the controller. This isn't just slow, it's incredibly stressful for the flight crew. It's so bad that pilots generally don't keep a continuous listening watch on HF. It's just too exhausting. That's why the CellCal system exists, the selective calling system. It basically sends a chime or a light in the cockpit when a message is specifically for that aircraft.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best